Graphene has many applications in many different areas, such as electronics, energy, medicine, mechanics, and further experiments examining graphene. As far as electronics go, it can replace the plastic we make our TVs and our cell phones out of. Pretty much anything made with circuit boards, plastic, or silicone can be transformed into a transparent, flexible item for our everyday use, such as a bendable newspaper that's completely plastic, kind of plastic, but something. And these new items will be made with batteries made of graphene. I know my cell phone battery doesn't last long, and I bet yours doesn't either, especially if you have a smartphone. With batteries made of graphene, you could go months without plugging your phone in once. And also, your laptop could run for days and weeks without having to be recharged. The holding capacity that graphene has is outstanding. It's pretty amazing, at least I think so. And with the holding capacity and the conductivity of graphene, things like solar panels and other transistors can be replaced and upgraded to be quicker, have higher holding capacities. These sort of things will be called ultracapacitors, since they hold double the energy of the capacitors we have now. Moving on to the field of medicine, graphene will be able to help fight cancer and bacteria, and allow us to view DNA one nucleotide at a time. There are researchers out there who have created a type of tumor blaster that reacts by combining two different drugs with graphene. This creates a very high cytotoxicity, which is the power to kill cancerous cells. This option has been proven to be more effective in killing breast cancer than the current treatment for colon cancer. Graphene is also very useful for viewing DNA and its structures. This can be used in learning more about our DNA, how it works, and whether or not we can manipulate it further than what we already have. First, just run the DNA through the nanometer size holes in graphene, add voltage, and then you can see DNA, each base at a time. A, T, C, and G. Not only is it good for cancer and DNA uses, it is also very useful for fighting bacteria and other infections such as E. coli. Graphene has the ability to destroy any bacteria that touches it, and researchers have tested the use of graphene against bacteria on the E. coli bacteria, and it was killed immediately after touching the graphene. Anyone concerned with drinking dirty, contaminated water? I found this on the Numeric website, and graphene has a solution to contaminated water with the use of a graphene straw. This straw works simply by layering a porous material with graphene and drinking from that. Impurities cannot pass through the graphene, therefore making the water on the porous material safe for you to drink. This can be helpful in third world countries for hikers and or anyone that needs a quick sip of clean water when there's no clean water around. The way I like to look at the future of graphene is kind of like watching the Jetsons, a futuristic way of living that may not be exactly how the Jetsons depicted it, but pretty close to it. Our cars may not fly, but travel on very thin, clear roads of graphene. And I did say travel because if it's on the graphene, we're probably not driving the cars. We're probably riding in them, and the cars being transferred on the graphene by themselves. The clothes we wear may not be made of cotton, but made of bodysuits of graphene that hold the capacity of every outfit imaginable. Technology we use could simply be bracelets that we fold onto our wrist when not in use, and unfold when we are ready to Google something. However your view on it may be, graphene is the miracle material of the future, and has little beginnings with huge endings, and will be the revolution of our time.